Hi there everyone, this is Ms. Page. In this lesson we are going to be talking about how to solve trigonometric equations that involve a double angle, such as sine of 2x or cosine of 2x. In a previous lesson we've solved other types of trigonometric equations. One of the skills or strategies that we have used is factoring. So we have this equation, sine squared minus sine of x equals 0, and we have a common factor of sine of x, which leaves us times sine x minus 1. Then we can use our zero product property and then use our knowledge of the unit circle to find the angles that have those sine values, and it would be over our interval from 0 to 2 pi radians. So it'll be very similar after we replace our double angle with something from our identities list. So this is one of the big things about these particular problems. So stay with me here. These problems are probably one of the most often missed in this particular unit. When we're looking at solving an equation that includes a double angle, the very first thing we're always going to have to do is use an identity to replace that double angle with something that doesn't have a 2x in it. It has just x. And that's probably one of the biggest things. You've got to look for that. And when you see a sine of 2x or a cosine of 2x, you have to use an identity to replace it. And then you can go on from there, very similar to how we've solved other equations. Many of these do turn out to be quadratic in structure. So we would want it in standard form. And then we can figure out, well, which strategy would be best, square root property, factoring. There are problems that also require the use of the quadratic formula because neither of the previous strategies work. We will not be looking at those types of problems in this lesson, but they do exist. Once we get to the point to where we have like sine of x equals 1, then we can find any angle measures that are appropriate over the given interval. Here are the double angles, the identities that we learned about in the previous lesson. So we have only one that we use for sine of 2x, or here it shows as 2 alpha. 2 alpha, 2x, 2 theta, all the same thing. We just change the alphas to whatever we're using for that angle symbol, x, theta, so on and so forth. We have 3, remember, for cosine, and we'll talk about, well, how do we figure out which one to use? Sometimes we have options. Sometimes one might be easier to use than another, and sometimes there might be an identity for cosine of 2x or cosine of 2 alpha that just doesn't work. We also, of course, have our tangent, and we only have the one of those. So if we're doing an equation that involves tangent of 2x, that would be the identity we'd have to use to replace it. All right. Let's take a look at this problem. So we're going to solve the equation over our interval from 0 to 2 pi. Remember, the bracket is with the 0, which means that if we're in that position, we use 0 radians, not 2 pi radians that it's coterminal with. And here is our equation. And here's the huge thing about starting this problem. When you see this and you read sine of 2x times cosine x minus sine x, you have to realize, okay, that sine of 2x with that 2 in front of it is going to have to be replaced using my identity. And I only have the one identity for sine of 2x, so this one is pretty straightforward. So I would replace that with 2 sine x cosine x. And then it would be times cosine x minus sine x equals 0. All right, so cleaning this up a bit, I have a cosine times a cosine. So this becomes 2 sine x cosine squared x minus sine x equals 0. So given the structure of this, it is in some ways quadratic because of the cosine squared. And so a strategy I'm going to use is factoring with a GCF of sine x. So I'm going to factor out that sine x. And that would leave me with 2 times cosine squared x minus 1. So now I have a product of factors equals 0. So I'm going to use my zero product property. So sine of x equals 0, or 2 cosine squared x minus 1 equals 0. This first one over here of sine of x equals 0, it's already, sine x is already isolated, so I can go ahead and I can find my angles for that. So sine is 0 at angles of 0 radians and pi radians. So that one is done. This one over here on my right side going to require a little bit more work. So I'm going to have to add 1 and then divide by 2. Now I have cosine squared equals 1/2. So now I have to undo the power of 2 by taking the square root of both sides. And in taking the square root of both sides, I get that plus or minus for my square root property. And this becomes cosine x. And my positive and negative square root of 1 is square root of 1 over square root of 2. Square root of 1 is 1. And rationalizing that gives me positive and negative root 2 over 2. And that is helpful because the square root of 1/2 is not what I see in my unit circle, but root 2 over 2, its rationalized form, is. And so this makes it easier for me to figure out what my angles are in my unit circle. So cosine is positive root 2 over 2 in quadrant 1 at pi fourths radians. And in the fourth quadrant at 7 pi fourths radians. Actually, let me move that over a little bit. That would be my last one. And then in the second and third quadrants at 3 pi fourths radians and 5 pi fourths radians. Comma in there. So we have these 4 angles here and those 2 angles there, no repeats. And so we get 6 angles in this one. All right, let's take a look at another problem. Okay, so here is the equation we're going to solve. Again, you really do have to practice these to recognize them as how different they are from the other types of equations we've solved. Otherwise, I get people doing crazy things like trying to factor out a cosine of x here, which just doesn't work, doesn't make any sense if you understand what cosine of 2x really means. So what do we do? Well, the moment we see this cosine of 2x, we realize we're going to have to replace it with one of our identities. Now for cosine of 2x, we have 3 identities. So which one should we use? Well, like I said earlier, sometimes you have choices and you can use all of them maybe. 2 of the 3 would work. Sometimes only one of them works. Sometimes one might be better than another in the sense that it makes the math easier, shorter work, fewer steps, that kind of a thing. But here's the strategy that I use to make my decision much of the time. And that has to do with what else is in the problem. So what else is in the problem is a cosine. So I would use an identity that changes cosine of 2x into something with cosine in it. So let's go back and take a look at our identities, which are here. So this one for cosine of 2x involves cosine squared and a sine squared. So I probably wouldn't use that one unless I have to. This one involves a sine squared. I don't have any sines in the rest of my problem, so I don't want to use that one. This one, notice, involves a cosine squared, and I have a cosine. So what this means is that using this identity, I could turn my equation into terms that have only cosines and the numbers involved. And so I would try this one. All right, so we have 2 cosine squared x minus 1 as our substitution. So this becomes 2 cosine squared x minus 1, and then plus cosine x equals 0. So again, this has a quadratic structure because of that cosine squared. So putting it into standard form, I would have 2 cosine squared x plus cosine x minus 1. So I get this trinomial structure we have seen before, and I would look at factoring it into 2 binomials. So for the 2, of course, I'm going to use 2 and 1, and for cosine squared, I split that into a cosine and a cosine. So I have 2 cosine x and 1 cosine x. And then my factors of my negative 1 here, I'm looking at using 1 and 1, of course. And let's see, if I want a positive cosine x, I should do a plus and a minus. That'll give me 2 cosine x minus 1 cosine x for my positive 1 cosine x. All right, so now I've got a product of factors equals 0. So my 0 product property says either 2 cosine x minus 1 equals 0 or cosine x plus 1 equals 0. This first one, I would add 1 and divide by 2, which gives me cosine of x equals 1/2. And the angles where cosine is positive, so cosine is positive, again, in the first and the fourth quadrant, and where it has a value of 1/2 are at the thirds. So that's going to give me pi thirds in the first quadrant. And what are we going to get? 5 pi thirds in the fourth quadrant. Over here for the other one, when I'm just subtracting 1, I get cosine x equals -1. And there's only one angle actually that is a cosine of -1, where x is -1, and that is pi. So that gives me a third angle of pi. All right, let's try a practice problem. Here you go. Pause your video. Give this one a try. All right, let's take a look at the result. So here, sine 2x, we are going to have to do a substitution for it with the only identity we have, which is 2 sine x cosine x. And then cosine x is a common factor. Times our 2 sine x minus 1, 0 product property, and cosine is 0 at pi halves and 3 pi halves, and sine is positive 1/2 at our 6 in the first and the second quadrant, pi 6 and 5/6. Let's look at another one. Pause your video. All right, let's take a look here. So this one we have a cosine of 2x we have to do a substitution for. Now, this isn't the only way that you could have done this one. If you have the same result, then I'm sure your math is fine too. This one takes and uses the identity that cosine of 2x is equal to 1 minus 2 sine squared x. And that turns this equation into an equation that it only involves powers of sine and then a constant term. So standard form gives us this, factored into binomials. This one then becomes very similar to the example I did that involved cosine. And 0 product property, where sine is negative, that's our y. So y is negative in the third and the fourth quadrants. Where sine is the halves is at the sixes. So that's why we get the 7 pi 6 and the 11 pi 6. And then where sine is 1, that is only one angle, our pi halves radians, which is equivalent to our 90 degrees. So we have these 3 angles. All right, let's look at another one. Pause your video here, try this one. All right, let's take a look. So this time we have the cosine of 2x that needs to be replaced. This one replaces it with the cosine squared identity, so 2 cosine squared minus 1. Again, if you ended up with the same result here and used a different substitution, then I'm sure your math is fine. This one we have like terms, the 2 cosine squared and plus the 2 cosine squared gives us 4 cosine squared minus 1, then adding 1 and dividing by 4, then taking the square root gives us a cosine of negative or positive 1/2. And where cosine is the halves is at the thirds. And that would be all 4 quadrants if we're both positive and negative. So we get all 4 of those angles. All right, and how about this one? Pause your video here. Let's take a look. You may have used the identity with the sine squared. I chose this one because the cosine squared is before the subtraction, whereas in the sine squared it's 1 minus 2 sine squared. This way I didn't have to deal with a negative sine squared term, but it's not, you could use either. And so this becomes this. -1 and -1 be a -2. Here if you factored out a 2 and did this, that's fine too, of course. That does work in this case. 2 can't be 0, so you ignore it. And then you still end up with cosine squared equals 1. Taking the square root, you get where cosine is -1 or +1, which is at 0 radians and pi radians. All right, that is the last problem in this lesson. So give your assignment a try and have a great day.